Hey guys, welcome to GER Hub Mathematics and Statistics lessons. In today's video, I'm going to be solving this problem. In other words, I'm going to be taking the square root of a surd of this nature, root 2 plus 5. So what could the answer be? Let's do it. So welcome back. We are going to be solving this problem in 5 steps, starting with a step 1. So in my step 1, we are going to make an assumption about the expected root. What will the expected root look like? So the thing I'm going to tell you here is that if you want to find the square root of root 2 plus 5, then we must make an assumption that the expected root should look like root 2 plus 5. So I'm going to write this as root m plus root n. Now one may ask quickly, why isn't our 5, why are we putting root n here when our 5 has no root? Okay, now take note, clearly they look alike simply because you could actually write this and this. Okay, so you would see the resemblance between root 2 and root m, and the resemblance between root 25 and root n. Of course, root 25 gives you 5. So what it means is that you can actually express the surd and its root in the same manner. Okay, so your root must look like the surd whose square root you want, and that concludes step 1. Assume that the root of the surd looks like this. And that brings us to step 2. So in step 2, we are going to square both sides and simplify. We are going to square both sides of the expression we've gotten previously and simplify the expression. So what we obtained earlier on was this. The square root of 2 plus 5 should look like the square root of m plus root n. Now, we are going to square both sides. Squaring both sides means squaring root 2, the square root of root 2 plus 5, all squared. It would equal the square of the square root of root m plus root n. Okay, now when you square the left hand side being the square of the square root of root 2 plus 5, of course you are going to end up having root 2 plus 5. Take note, the square of the square root of a number gives the number itself, and that means I'm going to put that here. If you take the square root of a and then square it, it will give you a. So the square of the square root of a number gives the number under the square root. So that's why the square of the square root of root 2 plus 5 will give us root 2 plus 5. And that settles the left hand side. Coming to the right hand side, squaring root m plus root n would give us root m all squared plus 2 times root m times root n plus root n all squared. Now, if you expand this, this is what you're going to get. Okay, now when you take the square of the square root of m, this would give you m. So again, from here, the square of the square root of a number gives the number, and this will give you 2 root mn, and then the last being the square of the square root of n, giving us n. Now I'm going to write this, I'm going to write this right hand side to resemble the left hand side, and doing that means this will give me root 2 plus 5 is equal to m plus n. I'm going to put this in bracket, plus 2 root mn. Clearly you would notice the resemblance between this, the right hand side, and this one on the left hand side. Now notice this. Okay, and notice this. So that concludes this step. So let's move over to step 3. In step 3, we are going to be comparing both sides of the simplified equation we got in step 2. So the simplified equation we got in step 2 was root 2 plus 5 equals 2 root mn plus n in bracket. Okay, so Clearly 5 is a constant. We are going to compare it with m plus n, and this is a root. We are going to compare it with this side that has a root, or this term that has a root. So I'm going to start with comparing the terms that have roots. So this would give root 2 equals to root mn. Okay, now I would stop at making the comparison. I'm going to simplify this before getting to the next comparison. So this would be root 2 equals to root mn. Simplifying this would mean taking the square of the square root of root 2 and equating it to the square of 2 root mn. Okay, so when you square the square root of 2, you're going to get 2 by the last thing we said in equation 2. And when you square the square, when you square 2 root mn, you are going to get 4. That is 2 squared times the square of the square root of mn, which is mn. So this can be written as 4mn equals 2. Now, if you simplify this by making mn the subject of formula, this will give you mn equals 2 over 4, which further can be simplified to give 1 over 2. Mn equals 1 over 2. Now I'm going to call this mn equals 1 over 2 equation 1. Now, that will bring me to the next comparison. Looking at this equation again, I'm going to compare constants. 5 and m plus n. So I'm going to write this as m plus n equals 5. And I'm going to call this equation 2. So in step 3, what have we done? We've compared both sides of the simplified equation we got in step 2. In step 4, we are going to solve the simultaneous equation we got from the comparison. The comparison in equation 3. So m equals 1 over 2n is equation 1. M plus n equals 5 is equation 2. So from equation 1, which is mn equals 1 over 2, clearly making m the subject of formula would give us 1 over 2n. Okay, so now substituting for m equals 1 over 2n in equation 2 gives, so putting m equals 1 over 2n in equation 2 means wherever we find m, we are going to be putting 1 over 2n. So let's do that. That will give us 1 over 2n plus n equals 5. Now clearly this can be written as 1 over 2n plus n over 1 equals 5 over 1. Now what is the LCM of 2n, 1 and 1? It is 2n. So I'm going to be multiplying this last equation by 2n. When you multiply the last equation, this, by 2n, the LCM, 2n will multiply 1 over 2n to give you 1. So I'm going to write here 1, okay? And 2n will multiply n to give you n 2n squared, okay? And 2n will multiply 5 to give you 5n, okay? 2n will multiply 5 to give you 10n, sorry. So I'm going to write 10n there. So this is what I'm doing. I'm using the LCM, which is 2n, to multiply both sides of this equation. So 2n will multiply 1 over 2n to give you this. And 2n will multiply n to give you this, 2n squared. And it will multiply 5 to give you 10n. Now, let's quickly rearrange this. I'm going to rearrange it to get 2n squared minus 10n when this is brought to the left hand side plus 1, all equals to 0. And that will make it look like a typical quadratic equation, okay? Now, the solution to this quadratic equation will be in n. And n can be written by the quadratic formula to be minus b plus or minus square root of b squared minus 4ac all over 2a, where a is the coefficient of n squared, and b is the coefficient of n, that is minus 10, and c is the constant term 1. So I'm going to quickly put those values in. Minus b, minus b will be minus 10, plus or minus square root of b squared, which is minus 10 squared, minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2 times 2. So this will give you 10, minus times minus 10, and this will give you plus or minus square root of minus 10 squared is 100, minus 4 times 2 will give you 8, okay? So we end up having this over 4. And this will be n equals 10 plus or minus the square root of 92, which is 100 minus 8 all over 4. Clearly, we can now see that our value of n is 10 plus root 92 all over 4, or 10 minus root 92 all over 4. Okay? Now, we won't stop here. After getting the values of n, we won't stop here. We are going to substitute for the values of n into any of the equation, either equation 3 or equation 2. Okay? Now I'm going to put the values of n in equation 3. Okay, so let me call this my equation 3. So remember, we had made m the subject of formula from equation 1, and we got 1 over 2n. So I'm going to put the value of n into this. Now when you do that, or if you choose not to, you could put it in equation 2. So putting it in equation 1 or in equation 2 gives you m equals 1 over 2n. Putting it in equation 3, that will be 2 in bracket 10 minus the root of 92 all over 4. Okay, so I'm putting this when n is equal to 10 plus root 92 all over 4. I'm putting it in equation 3, and doing that means writing m equals 1 over 2 times the value of n. In this case, my n is the first option, 10 plus root 92 all over 4. Okay, now, or that will give us m equals 1 over 2 in bracket 10 minus root 92 when n is equal to 10 minus root 92 all over 4. Okay, and that will give us any of these. Now you could simplify your values of m. Simplifying this first one will give you 1 over 2. 2 can cancel 4. 2 can cancel 4, and that will reduce m to 1 over 10 plus 92 root 92 all over 2, which gives you 2 over 10 plus root 92. Or you could have m equals 1 over 2 10 minus root 92 all over 4. Of course, 2 again will cancel 4, and that will give you 1 over 10 minus root 92 all over 2, and by reciprocal that will give you 2 all over 10 minus root 92. So any of these will be your m. Now to end the solution in step 5, we are going to write the root we have obtained. Recall that the square root of root 2 plus 5 was what we wanted, and I told you from step 1 that that root we seek must resemble root m plus root n. Okay, now what have we gotten for the values of m? When the value of m is 2 all over 10 plus root 92, this value of m, take note, came from n being 10 plus root 92 all over 4. Now when the value of m was gotten to be 2 all over 10 minus root 92, the value of n that gave rise to this value was actually 10 minus root 92 all over 4. I'm going to be verifying this result using any of these. In particular, I'm going to be using these to verify the result we've obtained. Meaning, we want to answer the question, is this root we have obtained for the square root of this really the square root of root 2 plus 5? Thank you for watching this video. Please like, share, and subscribe to the channel, and watch out for the verification in my next video.